What if adiabatic cooling, integrated system design, and a new approach to plant architecture could significantly reduce the energy required to support the next generation of high heat density computing? The PUE implications are substantial. Most facilities today operate in the 1.4 to 1.5 PUE range. This innovative approach moves closer to 1.2. Up to 12% more usable IT power, up to 90% less water usage, and that doesn't account for the potential billions of savings in electrical infrastructure costs. Less overhead, more power to compute, same site, better performance. That is the concept Havtech and our partners set out to prove. A single-loop cooling system design that changes the economics of hyperscale cooling by improving efficiency, reducing infrastructure burden, and creating more room for computing power. One of the core challenges in cooling today's high-density facilities is meeting two very different temperature requirements at the same time. Coolant distribution units may require approximately 90-degree water to reject heat from their direct-to-chip cooling systems, while fan wall systems may require approximately 68-degree water to support the air-cooled side of the environment. Traditionally, solving for both has required multiple chilled water loops and energy-intensive mechanical refrigeration through air-cooled chillers. That works, but it comes with complexity, energy overhead, and added infrastructure burden. So the question became, could the system be simplified without compromising performance? That question brought Havtech, Shumate Engineering, and BAC together to develop and validate a different path forward for direct-to-chip data center cooling. Shumate recognized the potential to eliminate air-cooled chillers and cooling towers in favor of a single chilled water loop built around an adiabatic cooler. The challenge was identifying a system capable of meeting the extreme operating requirements of the application. Havtech brought BAC to the table. The BAC Trillium Series hybrid adiabatic system offers a compelling solution. It could satisfy the temperature demands of the application while improving system efficiency by allowing the facility to operate in dry cooling mode for up to 90% of the year. Pre-cooling water is introduced only during peak ambient temperature conditions. Even then, it is recirculated, helping minimize water usage, reduce treatment requirements, and lower operating expense. At that point, the team had a compelling system concept. But concepts have to perform. As a result, Shumate's novel system design was put to the test. The R&D lab at BAC's world headquarters in Jessup, Maryland, is one of a few in the country capable of recreating extreme ambient temperature and humidity-controlled environments, allowing engineers to evaluate equipment performance under simulated real-world conditions. The goal was clear: evaluate system performance in dry cooling mode under hybrid adiabatic operation during peak summer conditions and across other critical operating scenarios.
So right now we're at the BAC test lab, and they have a Trillium product in the test lab where they can simulate the extreme weather conditions that we need for proof of concept for this product as part of a design for mission critical project.
During today's operation, we're running through several different test scenarios at some temperatures set up for a data center design to ensure it can meet the leaving water temperatures required for both dry operation and wet or adiabatic operation.
As we only really need water with the Trillium product when the ambient temperature gets above 82 degrees Fahrenheit or 81 degree Fahrenheit wet bulb. So we're basically cooling the data center dry without water all the way up to 82 degrees Fahrenheit, and we're only using water for about 10% of the year.
We're here to see if the machine really works. And what we've seen so far is quite promising. Why does our design matter? Basically, our connected PUE is 1.2. So if you're building a gigawatt of power, you need 1.5 gigawatts of power to your site to incorporate the IT plus the mechanical. With our design, that's 1.2 gigawatts. Well, what does that mean? That's 300 megawatts of generation that you don't need. It's substation you don't need, it's generation from the utility you don't need, or if you're building your own power plants, which is also the vogue, that's 300 megawatts you don't have to buy.
That kind of efficiency changes the equation for the entire facility. When power is constrained, efficiency creates advantage. Advantage powered by partnership. BAC, Shumate Engineering, Havtech, moving data center design forward.